Hello everyone, welcome to the Educon community new playlist or new series that is operating system. So let's continue with us. Here I will discuss some important topics and full-fledged topics of operating system for preparing GATE or computer science BTech or other courses. So let's continue. So, first of all, what is the operating system? So, what is the operating system? What is operating system? So, operating system is mainly basically a program that manages the computer hardware. Okay, computer hardware. Okay, it mainly manage the computer hardware part. It also provides the basis for application programs and act as a act as an intermediary between the computer user and the computer hardware. Okay, so it is the computer user and it is the computer hardware. Okay, so basically it makes the bridge between the computer user and the computer hardware. Okay, so it is the intermediary. It is the important point. Intermediary part. Okay, so an amazing aspect of operating systems is how varied they are in accomplishing these tasks. Mainframe operating systems are designed primarily to optimize the utilization of hardware. Personal computer operating systems support complex games, business applications, and everything in between. Operating systems for handheld computers are designed to provide an environment in which a user can easily interface or interact with the computer. So, now come to the part how the operating systems do any work. Okay, in overall computer system. Okay, so operating systems role in the overall computer system. Okay, so suppose it is user 1, this is user 1, this is user 2, u2, this is u3. Okay, in this way this is user n. Okay, so there are some parts like this is compiler. Okay, then comes to assembler. Okay, suppose assembler, then comes to text editor. Okay, then the database system. Okay, compiler, assembler, text editor, and database system. Okay, then this is suppose system application programs. System application programs. This is operating system and this is the computer hardware. Okay, this is computer hardware. Okay, so you may write down some points that first of all, the hardware. Okay, so the hardware, the central processing unit, the memory, and the input output devices provides the basic computer resources for the system. So here, CPU, the memory, and input output devices. Okay, this provides basic computing resources for the system. So this is the hardware part. Then the application program. Application program. Okay, such as word processors, word processors, then spreadsheets. Okay, spreadsheets, then compilers, and the web browsers. Okay, define the ways in which these resources are used to solve users computing problems. Then come to the next point 3. The operating system controls and coordinates the use of the hardware among the various application programs for the various users. Okay, then in this way we can also view a computer system as consisting of hardware, software, and data. The operating system provides the means for proper use of these resources in the operation of the computer system. An operating system is similar to a government. Okay, like a government, it performs no useful function by itself. It simply provides an environment within which other programs can do useful work. So to understand it more fully, the operating system's role, we next explore operating systems from two viewpoints, that of the user and that of the systems. Okay, so first come to the user view. Okay, the user's view of the computer varies according to the interface being used. Okay, so first it is based on the interface, first of all. Then most computer users sit in front of a PC, then consisting of a monitor, keyboard, mouse, and system unit. Such a system is designed for one user to monopolize its resources. The goal is to maximize the work that the user is performing. In this case, the operating system is designed mostly for ease of use, with some attention paid to performance and none paid to resource utilization. How various hardware and software resources are shared. Performance is of course important to the user, but rather than the requirements of multiple users, such systems are optimized for the single user experience. Okay, but in the other cases, a user sits at a terminal connected to a mainframe or mainframe or mini computer. Okay, mainframe or mini computer. Other users are accessing the same computer through other terminals. These users share resources and may exchange information. The operating system in such cases is designed to maximize resource utilization to assure that all available CPU time, um, then uh, memory, IO devices, means output devices used efficiently, and that no individual user takes more than her fair share. Okay. So in still other cases, users sit at workstations connected to networks of other workstations and servers. Okay. So okay, these users have dedicated resources at their disposal, but they also share resources such as the networking and servers. Uh, then this part file, compute, and print, then print. Okay, print the servers. So therefore, their operating system is designed to compromise between individual usability and resource utilization. Recently, many varieties of handheld computers such have come into fashion. Most of the devices are standalone units. Okay, so most of all the standalone units. This is an important point. So recently, many varieties of handheld computers have come into the fashion. For most of these devices are standalone units. One is uh, means one is coffee. Okay, for individual users. Some are connected to networks either directly by wire or more often suppose with wire or without. The wireless modems and networking, because of power, speed, and interface limitations, they perform relatively few remote operations. Their operation systems are designed mostly for the individual usability, but performance per unit of battery life is important as well. Okay, so important is the battery life, performance per battery life. Okay, performance per battery life. This is the important as well. Some computers have little or no user view. For example, embedded computers in home devices and automobiles may have numeric keypads and may turn indicator lights on or off to show status. But they and their operating systems are designed primarily to run without user intervention. Okay. Then comes to the system view. Come to the system view. From the computer's point of view, the operating system is the program. So main form is program, most intimately involved with the hardware. In this context, we can view an operating system as a resource allocator. Okay, resource allocator. A computer system has many resources that may be required to solve a problem. CPU time, these types of problems. CPU time, then memory space. Okay, then file storage space, Okay, then IO devices and so on. The operating system acts as the manager of these resources, facing numerous and possibly conflicting requests for resources. The operating system must decide um, how to allocate them to specific programs and users so that it can operate the computer system efficiently and fairly. As we have seen, resource allocation is especially important where many users access the same mainframe or mini computer. A slightly different view of an operating system emphasizes the need to control the various IO devices and user programs. An operating system is a control program. Okay, so I have written this, and this is mainly control program. Okay, a control program manages the execution of user programs. Okay, to prevent the errors and the improper use of the computer. It is especially concerned with the operation and control of IO devices. Okay, I can write about the control program. What is control program? A control program manages the execution of user programs to prevent the errors and improper use of computers. Okay, so it's especially concerned with the operation and control of IO devices. Yeah. Okay. So now we will discuss about the operating system operations. Okay, operating system operations. OS operations. So firstly, dual mode operation. Okay, dual mode operation. In order to ensure the proper execution of the operating system, we must be able to distinguish between the execution of operating system code and user defined code. So firstly we have to distinguish between the execution of distinguish distinguish. Okay, this is distinguish between operating system code and user defined code. Okay. The approach taken by most computer systems is to provide hardware support that allows us to differentiate among various modes of execution. At the very least, we need two separate modes of operations that are user mode and the kernel mode. Okay. User mode and kernel mode, also called the this kernel mode can be also called as the supervisor mode, okay, or admin mode or system mode or the privileged mode, okay, privileged, or the admin mode, okay. So a bit called the mode bit. Next term is mode bit. This is added to the hardware of the computer to indicate the current mode. Okay. If kernel, then it indicates as 0, and if user, then 1. With the mode bit, we are able to distinguish between the task that is executed on behalf of the operating system and one that is executed on behalf of the user. So it distinguishes also the task. Between OS and user. Okay. When the computer system is executing on behalf of a user application, the system is in user mode. However, when a user application requests a service from the operating system via a system call, there must be a transition from user to kernel mode to fulfill the request. Okay. So as we shall see, the architectural enhancement is useful for many other aspects of system operation as well. At system boot time, okay, so at system boot time means the booting time, hardware starts in kernel mode. Okay, the operating system then loaded, then OS loaded, and then starts user applications in user mode. Clear? So firstly, hardware starts in kernel mode, then operating system loaded, then starts the user applications in the user mode. Okay, clear? So whenever a trap or interrupt occurs, the hardware switches from the user mode to kernel mode. Means one means 1 to 0, as user mode is 1 and kernel mode is 0. So convert it user mode to kernel mode. Okay, that is changes the state of the mode bit to 0, 1 to 0. Okay. Thus, whenever the operating system gains control of the computer, it is in the kernel mode. The system always switches to user mode by setting the mode bit as 1 before passing the control to a user program. The dual mode of operation thus provides us with the means for protecting the operating system from errant users and errant users from one another. We accomplish this protection by designating some of the machine instructions, thus may cause harm as the privileged instructions. Okay, so how the user to kernel mode is transition occurs, I here I will show you. Just wait. This is the user process. Okay, so user process executing here. Then call the system call. Then it is the kernel process. When system call, then tap mode bit 0. Then execute the system call. Okay, then return mode bit 0 to 1. Then it return from the system call. Okay, so this is user mode. So user mode, so mode bit is here 1, and this is the kernel mode, so mode bit is 0. So this is the transition from the user to the kernel mode. Clear? I think this is clear to you. Okay. Now the hardware allows the privileged instructions to be executed only in the kernel mode. If an attempt is made to execute a privileged instruction in user mode, the hardware does not execute the instruction, but rather treats it as illegal and then traps it to the operating systems. The instruction to switch to user mode is an example of the privileged instruction. Some some other examples include input-output control, timer management, and interrupt management. As we shall see throughout the text, there are many additional privileged instructions. We can now see the life cycle of instruction execution in a computer system. Initial control is within the operating system where instructions are executed in kernel mode. When control is given to a user application, then the mode is set to the user mode. Eventually, control is switched back to the operating system via an interrupt or a trap or a system call. Okay. System calls provide the means for a user program to ask the operating system to perform the tasks reserved for the operating system. On the user programs, we have a system call is invoked in a variety of ways depending on the functionality provided by the underlying processor. In all forms, it is the method used by a process to request action that can only be performed by the operating system. A system call unusually or usually takes the form of a trap to a specific location in the interrupt vector. This trap can be executed by a generic trap instruction, although some systems, such as the MIPS R2000 family, or have a specific system call instruction. Then, when a system call is executed, it is treated by the hardware as a software interrupt. Control passes through the interrupt vector to a service routine in the operating system, and the mode bit is set to the kernel mode. The system call service routine is a part of the operating system. The kernel examines the interrupting instruction to determine what system call has occurred. A parameter indicates what type of service the user program is requesting. Additional information needed for the request may be passed in registers on the stack or in memory with pointers to the memory locations passed in the registers. The kernel verifies that the parameters are correct and legal, executes the request, and returns control back to the instruction following the system call. The lack of a hardware supported dual mode can cause serious shortcomings in an operating system. For instance, MS-DOS was written for the Intel 8088 architecture, which has no mode bit and therefore no dual mode. A user program running away can wipe out the operating system by writing over it with data, and multiple programs are able to write to a device at the same time with possibly disastrous results. Recent versions of the Intel CPU, such as the Pentium, do provide dual mode operation. Accordingly, most contemporary operating systems, such as Microsoft's Windows 2000 or Windows XP and Linux and Solaris for x86 systems, take advantage of this feature and provide greater protection for the operating system. Once hardware protection is in place, errors violating modes are detected by the hardware. These errors are normally handled by operating system. If a user program fails in some way, such as by making an attempt either to execute an illegal instruction or to access memory mm, that is not in the user's address space, then the hardware will trap to the operating system. The trap transfers the control through the interrupt vector to the operating system, just as an interrupt does. When a program error occurs, the operating system must determinate the program abnormally. This situation is handled by the same code as is a user requested abnormal termination, an appropriate error message is given, and the memory of the program may be dumped. The memory dump is usually written to a file so that the user or programmer can examine it and perhaps correct it and restart the program. Okay, so now we will learn about the operating system services, but this will be in the next part of the video. So that's all for this part. Thanks for watching. Do like, share, and subscribe for getting such tutorials. Thank you.